Assalamualaikum and hi everyone. Today we're gonna do the experiment that involves multimeter and error in experimental data. In this video, you can see that we use component which is decade resistor, decade capacitor, and decade inductor, the white thing. Most important thing, don't forget the multimeter and the LCR meter. Last but not least, make sure you got the jumper, so make sure you got it enough.
First of all, we must calibrate our digital multimeter. After we calibrate, we must measure the resistance to know the value, and the value of this resistance is 9.73 ohm.
This is the way for us to measure the value of winding resistance in the inductor component using a digital multimeter. Set the multimeter to the ohm range and touch the positive and negative probe of multimeter to the leg of the inductor component.
For the capacitor, we just need to change the multimeter to the capacitance, and then you can place the probe to the correct terminal, positive and negative, so then you can read the reading at the multimeter. So you can take the data and record it.
Secondly, I like to measure the inductance by using LCR meter, and the value of inductance is 2.574 Henry.
This is the method of testing the measurement to measure the voltage of the resistor. We set the supply DC voltage to a value of 10 volt and connect the supply to the leg of the resistor and take the voltage measurement on a digital multimeter. We set the multimeter to the direct voltage range and touch the positive and negative probe on the resistor leg.
First, make sure the probe in the required socket so that the multimeter can be measured through the current resistor, and also the range of the current is within the range of selected required, so we can measure the resistor of the current and then you can read the reading.
For the current measurement test on the RCL series circuit, we set the resistor value to 10k ohm, the capacitor value to 10 microfarad, and the inductor value to 2 Henry. We set in at the inductor, we set the value is 2 Henry. We set it to the digital multimeter on the microampere range and select option on the alternating current reading. We open the negative supply and connect the negative supply with the negative probe of the multimeter, and the positive probe of our multimeter connect the connection to the series circuit RCL. From this way, we can get the reading of current in the series circuit connection.
The value of voltage through resistance is 1.67 ohm. From the AC supply, the value of voltage through capacitor is 0.024 microfarad. From the AC supply, the value of voltage through inductance is 0.247 Henry.
Now we want to calibrate the oscilloscope by connecting the ground tip to a ground and touch the probe tip to a test point. Then press the auto scale button. Now we need to measure the waveform for the resistor. Put the positive probe on the positive leg resistor and the negative probe on the negative leg of the resistor. Set up the oscilloscope we can see the waveform. After that, press the auto scale button to get the waveform. Now, we can observe the waveform. Based on the circuit, as you can see, the VRMS value we set is 1.77 volt and the frequency is 100 Hz. The value of the resistor we use is 10 kilo ohm, while the inductor is 2 Henry and the capacitor is 10 microfarad. Now, we want to measure the voltage value, resistance, capacitance and inductance. We need to connect the multimeter in parallel in order to get the voltage value. We need to double click the multimeter icon to display the multimeter reading. After that, we click on the voltage and AC symbol to change the ampere to voltage and from DC to AC. Then, run the circuit to get the readings. Next, turn off the circuit. From this, we get the resistance voltage value is 1.759 volt and the capacitance is 221.801 millivolt and the last for inductance is 27.911 millivolt.
For the measured current at this same circuit RCL, we also use the same value VRMS, 1.77 VRMS and 100 Hz for measured the current. At this simulation circuit series RCL, we put the multimeter at component resistor 10k ohm, capacitor 10 microfarad and 2 Henry for inductor. We connect the multimeter in series to measure current at each component. The result we get from the simulation for measure of current is 175.935 microampere.
At the end of this video, we compare between measure and simulation value of voltage and current. Now, for the discussion, we also compare of the percentage of error. We calculate 4 types for percentage of error at current, voltage capacitor, voltage inductor, and voltage resistor. And then we also calculate for the absolute error, which is the formula is nominal value minus actual value for the current, voltage resistor, voltage capacitor, and voltage capacitor inductor.